On to our third speaker for this event, Dr. Mindy Nicewonger. Dr. Nicewonger is a postdoctoral fellow at the National Oceanic and Atmospheric Administration.
Hi, everyone. Thanks so much for having me today. So what do you want to be when you grow up? This is a question that we have all been asked multiple times throughout our childhoods. For me, there was never any hesitation. I wanted to be a scientist. In fact, when this question was posed to me during high school graduation, I wrote, work for NASA or the national government, become a tornado chaser, and one day go to Antarctica to study the climate and weather of the world. Well, 12 years later, I have done two of those things. I have yet to chase a tornado, though. This is the story of me accomplishing my dream of conducting research in the coldest, driest, and windiest place on Earth, Antarctica. But first, let's take a moment to describe how I even got to the position of being asked to go to Antarctica. I grew up in Texas. My parents had divorced when I was 10, and I was supported by my amazing mother. I was the first person in my family to graduate college when I did just that in 2013 from Texas A&M University with a major in meteorology or atmospheric science. While at A&M, I became really interested in geology and the past climate of Earth after taking a historical geology course as an elective. Many of my peers were joining organizations and taking internships, which could benefit their future career options. But I worked nearly full-time at a local fast food restaurant to financially support myself, so that greatly limited the internships and opportunities I could take. And by the way, if we really want to diversify science, we need all internships to be paid, but that's another speech for a different time. Anyway, I found a really great opportunity called an REU, a research experience for undergraduates, after heeding the advice of a fantastic professor and mentor at Texas A&M. REUs are a paid 8 to 10 week long research program funded by the National Science Foundation. I applied for several of these programs and was accepted into the UC Irvine Earth System Science 2012 REU program. My research topic, ice core trace gases. So what are ice cores? Ice cores are cylindrical samples that we drill out of the polar ice sheets, Greenland and Antarctica, as well as high elevation mountain glaciers. These cold regions form a unique type of ice, an ice that cannot be formed in our at-home freezers. Basically, as snow falls year after year in these very cold places, it doesn't melt, but rather accumulates and slowly compresses. And as that snow compresses, it turns into what we call ice. But trapped inside that ice are tiny air bubbles of the ancient atmosphere. And so we can actually look at these air bubbles through time and see what was in our atmosphere. In the UC Irvine Ice Core Laboratory, the air is removed from the ice core samples, and analysis is done to measure the amounts of different gases. This same type of research is how we know the amounts of carbon dioxide and methane, the very potent greenhouse gases, in our atmosphere for the past 800,000 years. In the UC Irvine lab, we were looking at gases that are 1 million times less abundant than carbon dioxide, what we call ultratrace gases, or gases that are found in very small amounts in the atmosphere. These gases are interesting because they can inform us about different cycles in the Earth system, like how many plants there were on land through time, or how wildfires varied through time. After my summer at UC Irvine, I was hooked and decided to apply for graduate school. I will admit that in college, I had absolutely no plans to attend graduate school because I honestly didn't even know what it was. I call this the first generation bubble. But lo and behold, I was accepted back into the Earth System Science Department at UC Irvine for graduate school to work with ice cores. And just a few months into my first year of the program, I found out that my advisors had been funded to drill a new ice core at the South Pole, and they would need somebody to go into the field to help with this project. I was first on their list. My dream was coming true. I was going to go to Antarctica for a full 3 months. There's quite a bit of prep work to travel and work in Antarctica. First, you must be physically cleared to go, meaning you have to have lots of blood work taken and medical exams to ensure that you're healthy. Then there is the packing. What in the world do you pack to go to Antarctica? The US Antarctic program would provide me with some extreme cold weather gear, like a jacket and boots, But what about all the other things I would need over the course of 3 months? It's not like there's a target at the South Pole that I can just run out to if I forget something. Like the planner I am, I began packing a whole month before departure. I laid out everything I could think I would need and then some. In the end, I did pack way more than I needed, but I was happy I had lots of chapstick and lotion with me. Antarctica is truly the driest place on Earth, and it does a number on your skin. The travel to the South Pole is an epic adventure of its own. It takes roughly 5 days of traveling with a few stops along the way. For me, I had an 8-hour layover in Sydney, Australia, which allowed some time for exploration, like the big sites, like the Harbour Bridge and the Opera House. And then I was off to Christchurch, New Zealand, where I would get all of my extreme cold weather gear. This jacket here is called the Big Red, and it's the warmest thing you could ever wear, but it's also pretty bulky, as you can see in the picture. But it definitely keeps you warm when it's minus 60 degrees Fahrenheit outside. That's a minus 60. After getting geared up, it was time to head to Antarctica. We flew a US Air Force C-17 into McMurdo Station, one of the coastal bases maintained by the United States. These military planes are incredibly loud, and as such, you must wear protective earplugs. Another difference with flying with the military is that passengers are actually allowed up into the cockpit as we were flying over Antarctica. I got to actually see my first glimpse of the continent I had always dreamed about from the cockpit. Once in McMurdo, we waited for good weather before we boarded a different US Air Force plane, a C-130 Hercules, that would take us to our final destination, the South Pole. When we arrived at the South Pole in mid-November, the location where we were going to drill into the ice to collect the South Pole ice core, also called the Spice Core, was just a flag on the plateau. The first few weeks involved the Spice Core team, myself and 10 others, and crew members of the South Pole Station digging into the snow and building the tent, which would protect us from the elements and house the mechanical drill. Here are some photos of us getting the tent and everything set up. There was a lot of digging and moving snow. Eventually, everything was set up and ready to go. This is a view of our site from a plane. And on December 8th, 2014, we successfully drilled into the ice sheet at the South Pole and brought up our first 6-foot section of ice core, or 2-meter section. The upper portion of the ice sheet is mainly just compacted snow, and it takes several meters below the surface before we reached what we consider bubbly ice, or the ice that has the bubbles of ancient atmosphere inside. We were so excited when we got to that point because, as a trace gas scientist, this is the ice we were looking for. At the South Pole, we reached this bubbly ice depth at about 400 feet below surface. We worked 6 days a week and about 10 to 11 hours a day, so it definitely wasn't a vacation. The temperature in the tent where we spent most of that time was always well below freezing, usually around 0 degrees Fahrenheit. My job was to ensure that the ice core samples were measured, labeled, and packaged safely so that they would make their journey back to the United States. It's important to know the depth the ice came from because that is how we determine the age. So I got exceptionally good at math in the cold. For reference, here's our logbook. Each time the drill went back into the ice sheet to pull up more ice, it would take longer and longer. Eventually, the time between the drill runs, as we call them, became so long that that I had to occupy my time somehow. I actually skipped some photos here. Anyway, these are the pictures of all the ice packed up, and this is the ice making its way back on the plane to head out to McMurdo Station. So each time the drill went back into the ice sheet, it took longer and longer between these runs. And so I had to occupy my time somehow. And sometimes the time difference between when the ice came up could be anywhere between 45 minutes to over an hour and a half. And so I occupied my time a lot of times by reading. And so in this picture, the white wall behind me is snow, and the box I'm sitting on was the heated glove box. So it was the best place to take a break. We did actually have an indoor heated break room, but it gets pretty exhausting after a while, taking clothes on and taking clothes off. For reference, here's what my normal daily routine was getting dressed to go outside. So you can see I put on multiple layers of clothing. The South Pole Station is an amazing place. In terms of field work, it's a bit posh. We actually sleep indoors in a heated building at night, and there's so many activities to take part in. There were roughly 150 people at the station, all with unique backgrounds and personalities. I really got involved with the volleyball team, and near the end of the 3-month season, I was playing volleyball about 3 or 4 times a week in the evenings. Antarctic fieldwork typically lasts from November to February, and you'll know that there are many holidays during that window of time. The station puts on a fabulous feast for both Thanksgiving and Christmas, and I also celebrated Hanukkah with several of the folks I met at the pole. Another fun event that happened for me is my birthday. I turned 24 in 24 hours of daylight. By far the best birthday I've ever had. Another perk of working in extreme cold environments is the food. You need calories to stay warm, so when you're in a really cold place, you have to eat more food. So we ate all types of yummy treats. By the end of the 3 months of munching on Oreos, I can tell you that I actually don't really enjoy them much anymore. In February, it was time to start packing up and preparing the ice core drill site for winter. Because come February, there are no more flights in or out of the South Pole because temperatures drop so low there that jet fuel can freeze. On my way back to the States, I got to see my favorite animal, a penguin, but just one and from really, really far away. Once I got back to UC Irvine, the fun actually really begins. The ice cores we drilled at the South Pole had been shipped by boat back to the United States and then driven by refrigerated trucks to the National Science Foundation's ice core facility, which is located outside of Denver, Colorado. These ice cores arrived into the ice core facility in late March. And in June, I headed back to the ice core facility to work on what we call the core processing line. This multi-week long event consists of many scientists and helpers working in a walk-in freezer for roughly 8 hours a day. You can see the temperature of the freezer here in this figure. Several research laboratories collect samples from the ice cores and ship these samples back to their respective labs to do their analysis. My job was to oversee the gas samples. So we have our big ice core and we're only taking small samples from it. So overall, I cut thousands, and yes, I mean thousands of samples, packaged them up, and sent them all to the different laboratories that requested them. At UC Irvine, we actually ship our samples overnight by FedEx, so nothing super fancy, but we do ship them in insulated boxes with heavy-duty ice packs. You can see the ice packs are the blue things in this picture. And once safely tucked away inside our freezers in our lab, then I can actually do the research that I set out to do. So my research was focused on understanding how wildfires changed in the past and what this could tell us about the future planet and the future Earth. To do this, I was looking at gases that are unique to wildfires in those ancient air bubbles. For each ice core sample, I worked in a walk-in freezer to prepare the ice for analysis. And then once prepped and ready to go, I loaded the ice into a chamber where then we would melt the ice and slowly release those trapped bubbles of ancient atmosphere. So in this video, we're watching an ice core sample melt, and this is always super mesmerizing to me. This sample is about 3,000 years old, and so we're literally watching and looking at air that is 3,000 years old. As the air bubbles escape the water and build up in the glass chamber, we can then collect that air and analyze it for the abundance of different gases. So once the ice has been completely melted, the collected air is analyzed using some instruments that kind of have complicated names, but they do two simple things. Gas chromatograph or gas chromatography separates out the air into the different gases we're interested in looking at. And then we have a mass spectrometer, which detects the amount of each of those different gases. So on any given day, I could prep, melt, and analyze at most 2 individual ice core samples. So after many months and quite frankly, many years of work, we finally can create a history of the different gases in the atmosphere. So here's a record of the gas that is going to tell us about wildfires. This gas is called acetylene. So the top points here show the abundance of this gas over Greenland for the last 2,000 years, measured in Greenland ice cores. And then the bottom shows the abundance over Antarctica, measured in Antarctic ice cores. And so to orient ourselves, this unit of measurement in time is calendar year. So today, year 2020, is going to be over here on the right. And so we're looking at 2,000 years being on the far left here. And so the unit of measurement for acetylene is what we call a part per trillion. So for every million molecules of air, we were only measuring between about 20 and 120 molecules of acetylene. But if we focus just now on the Antarctic record, I've zoomed in, there's actually some interesting things that we observe. First, we see that the acetylene levels are high for about 1,500 years and then decline quickly starting around 1,500 CE. So I've highlighted what the climate was like during these two different periods. Here in the reddish color, the climate was actually warmer during the time period known as the medieval warm period. And this is when we saw more acetylene, and this means there had to have been more fires. The climate cooled a bit during the Little Ice Age, during the blue period here, and there was less acetylene over Antarctica, which means there had to have been less fires. And if we use some computer models, we actually can find that the variability in acetylene was due to tropical wildfires decreasing during this 1,500 period. So the big picture question here from this research is, what does this mean for our future planet? Well, global temperatures are increasing at a rapid rate, and it's obvious from the ice core records that the wildfires are somehow linked to temperature, kind of in a positive way, meaning when temperatures get warmer, we see more fires. We can speculate that wildfires are going to become more frequent and more intense, as been observed over the past few years in California, Oregon, Colorado, where I live now, Australia, and elsewhere around the world. So we can look at the past to help us predict the future, but what is important to remember is that there's one big difference between 1,000 years ago and today, and that is people. There are billions of people on this planet, and predicting how humans will behave is chaotic. What will happen to our planet in the coming decades and centuries depends on our actions now. So what have I learned through all of this? Well, first and foremost, always do what makes you happy and what interests you. The origins of our interests begin as children. So now I ask you, what do you want to be when you grow up?
All right. That was a really great adventure and also really amazing insight, Dr. Nicewonger. Thank you. And now it's time for some Q&A. So again, feel free to submit any questions into the chat bar, and we'll put them up on the screen. But just to start out with, I was just curious, what were the people like you were hanging out with in Antarctica, and what other activities did you do in your spare time? Not that it sounds like you had very much spare time.
Yeah, so that's a great question. So the station has about 150 people. That's the capacity of the station. And I would say really only maybe 45 to 40%, 40 to 45% of those people are scientists, and the rest are people that maintain the station. So we have, chefs and people working in the galley or the kitchen. Then we have heavy machinists, right? So we have people that know how to use the big tractors and things to help us move our equipment around. There's plumbers and electricians and carpenters. And so when I say these people are coming from diverse backgrounds, they really are. Some people understand climate change, some people don't. And so a lot of times at dinner, it's just mingling with people and informing them why we're down there and why we're doing what we're doing. In terms of other things I did in my spare time, I watched a lot of The Big Bang Theory because they had all of the seasons on DVD. And yeah, I mean, volleyball was really it. And, sleeping when I could get the opportunity.
Awesome. Okay, so Chili Willy says, did you use carbon to date the ice?
Yeah, that's a great question. So we do not use carbon to date the ice. We actually can count the layers in the ice. So similar to how a tree ring has unique layers each year as the tree grows, you can actually visually see layers in the ice. And there's also other ways. Sorry, my cats are freaking out. There are other ways that we can date the ice. We can look at volcanic signatures. So when a volcanic eruption happens, it releases different chemicals into the atmosphere, which act to acidify the atmosphere. And so if we run electrical current over the ice core, we can actually see when the ice becomes more acidic or less acidic. And we can actually use the volcanic layers as a method to date the ice. And honestly, I could probably talk for another 15 minutes about how we date the ice, but the main way is that we actually count the individual layers.
That's super cool. So fascinating. I also love that video of the air bubbles coming out. That was awesome. Okay, so Zinal Patel says, how do all the buildings in the Antarctic have so much energy to keep warm?
Yeah, and so this is actually kind of part of a trade-off that we have to do as scientists is we are using fossil fuel, unfortunately, to power the buildings. So all of the buildings in Antarctica, at least the South Pole Station right now, is warmed by generators, and those generators use jet fuel that is brought in by the planes that land there. So anytime a plane comes in, they offload some fuel and they leave enough fuel on the plane to get it back to where it was coming from. But unfortunately, we do use fossil fuels. Maybe one day the technology will be there that we can have cool solar panels and cool wind turbines at the South Pole. But one thing we have to think about is the South Pole is super cold, and that really impacts electronics and all types of infrastructure.
Yeah, I think that's fascinating. It's something that you probably don't think about when you're going down there, or just the average person, all of these logistics about how to make the whole entire thing work. It's really cool.
Yeah.
All right. So Melody H asks, what are some advice for students interested in research in the South Pole?
Yeah, so there's many different ways to do it. So you can obviously go into research. I was talking about ice cores, but the South Pole is an amazing place for what Maggie had talked about, looking at our galaxy. So the air is really dry there, so you don't get interference between water vapor and space. So you can look at, galaxies. There's a huge telescope down there. So if you're into physics, there's a lot of physical observations down there. There's multiple ways. The main way is obviously doing research. But there's also, like I said, all the people that work there. So if you want to take a year off after you graduate college, I actually knew like 10 people that were there doing that. You get paid to work down there, you get room and board, you get food, and it's a really cool experience.
Yeah, it sounds like it. I think it would be fascinating just to live in such a different place for a year, doing whatever, really, honestly. All right. So TEDxUCR asks, what was your best memory spent in Antarctica?
Oh, there's so many good memories. I just think it is kind of getting away from the world. It's kind of weird, but we didn't have a lot of internet. I didn't have a cell phone. I mean, I have a cell phone. It wasn't working. There's no internet down there. There's no cell phone service. We were always a little bit delayed in finding out news. And so it was kind of nice to check out and just learn to talk to people and like not sit on my phone and scroll through Twitter or Facebook, whatever it is. And just really get to talk to people and know people and understand where they're coming from and just not be immersed in my technology. So that was the best memory of Antarctica.
Awesome. Okay. So last question. Jen Campos Ayala asks, you have achieved a lot and have dedicated a lot of time into giving back and educating others in many capacities. How do you do it all?
Hi, Jen. Jen is a student, a graduate student who took over my research at UCI. So she needs to be proud of herself as well. My philosophy is that people helped me get where I am today, right? I was a first generation student. No one in my family, even now they still maybe don't know what I do. I see my brother is on the chat, so he's watching. But it's kind of your duty, right, to give back to people that have helped you and to make sure it's easier for other people to make it. And so, yeah, I enjoy it. I think another thing that's important to remember is that all of the work we're doing is paid by taxpayers. And so it's very important that we let people know what we're doing and why we're doing it, because it's their contribution just as much as it is mine. So that's how I do it all.
I think that's a fantastic point. And we actually have one more question. So DJ Motoset asks, was it jarring coming back after taking that leave from the real world?
Yeah, and that's a great question. And I'm going to say yes, because one thing I didn't mention either is that it's really, really quiet at the South Pole, right? We only have 1 or 2 planes that may be coming in every day. Even then, they didn't come in every day. There was issues with weather. So you don't have somebody blowing leaves down the street. Since I've been working from home, I realized just how much noise there is in our daily lives, the dog barking next door. You don't have that. And so when I came back, I flew back into New Zealand to make my way back. And just like hearing people's phones vibrating and like all of the noise that we didn't have was really kind of jarring. And also a lot of things happened while I was at the South Pole. So there were, police shootings of Black men in America. I wasn't really tuned into that. So I came back to a world that was changing and that was different. But yeah, so it took a while to adjust to the new world.
Yeah, it's fascinating. All right, so that is all that we have for Q&A.
Thank you, Dr. Nicewonger, for your time today.